Good day. My name is Шагимолдина М О. I am biologist teacher in Nazarbayev Intellectual School of Astana. Today our topic will be how do we move? As you already guessed, today we will talk about skeletal and muscle systems. Think about this. Bones are so tough and strong. In fact, that it's easy to think of them as so they were nothing more than rigid, lifeless supports for the rest of body. If that were true, what would happen if one of those supports broke? Broken bones, as you know, can heal. How does that happen? And what does that tell you about the nature of our skeleton? Objectives of our lesson. Describe the main functions of a vertebrate and a skeleton. Distinguish between cartilage and bone. Describe the structure of bone. Describe muscle contraction. Principle of locomotion. Most animals are able to move from one place to another in what is generally known as locomotion. To change position, animals have a variety of strategies including swimming in fish, walking, arthropods, and flying birds. The force for movement is created by muscle contraction when the muscle cell shortens its length. Animals require a skeleton to provide leverage for movement. Some examples of skeletons include hydroskeleton in earthworm, exoskeleton in arthropods, and endoskeleton, fish, birds, and we are humans, mammals. Earthworm, hydrostatic skeleton. Look at this earthworm. I guess most of you see earthworm in your life. Think how earthworm go or walk. This annelid worm uses a hydrostatic skeleton for leverage. Normally, the earthworm spends all of its time beneath the surface of soil. This organism is well-known decomposer which consumes organic debris in soil. Look at this picture. Yeah, this is cross-section of the body of this worm. You see here the annelid earthworm has a body divided into segments. Each segment is filled with coelomic fluid. Each segment is partially separated by a wall, septor, and the wall is composed of circular and longitudinal muscle. Other organ systems such as the gut passes through these segments. Leverage against the ground is provided by setae, which brace against the soil. Look at this red labels. Yeah, you see here that this worm has longitudinal and circular muscle. And look at place where written fluid-filled compartments. This exactly fluid-filled compartment give worm its exact fixed shape. Producing movement, muscles. The force for movement is generated by the concentration of contraction of muscle cells This shortening force applied to the skeleton that provides the leverage to either magnify the movement or the force. To achieve this effect, muscles work in antagonistic pairs. As one muscle contracts, providing the pulling power, the other relaxes and is compliant. When the limb bends, this is called flexion, and when the limb is strengthened, is known as extension. Producing movement, bones. Bones are the levers of the skeletal system. If we will divide into parts, passive movement and active movement. Passive movement allows us bones and joints. Active movement is muscle, provided by muscle. Bones magnify movement or the force of muscle contraction, also provide support and protection for organs and tissues. Joints. Muscle attached to bones by tendons, non-elastic at the point of origin, and then again to another bone at the insertion point. Joints between the origin and insertion points. The joints at the fulcrum, pivot of the skeletal lever system. Some joints provide a wide range of movement for locomotion, example, human arm. Others are more restricted and provide stability for the skeletal system. Function of bone. Function of skeleton. Protection. Example, the cranium of the skull protects the brain and the rib cage protects the lung and heart. Support. The skeletal skeleton supports the soft body tissues, allowing us to stand. Movement. Bones provide a solid structure for muscle attachment. Manufacture of blood cells. The marrow of some bones produces blood cells. Mineral storage. Calcium is very important in, for example, muscle contraction and blood clotting. The bones provide a store of calcium ions. The basic functions of bone is protection, support, movement, manufacture of blood cells, and mineral storage. Bones are classified by shape, like long bones, short, flat, irregular, and round bones. Bone enclosed in peristome, which is continuous with tendons and ligaments, blood vessel in peristome. We could divide long bones into two parts, epiphysis and diaphysis. Epiphysis ends spongy bone contains red marrow, compact bone, articular cartilage. Diaphysis middle, compact bone, medullary cavity, contains yellow marrow, fat, and lined with endostome. Look at this picture of bone. In this picture you see femur, yeah? As we said, we could divide this long bone into basic parts, epiphysis and diaphysis. Two ends of this long bone we call epiphysis, and in the middle we see diaphysis. In epiphysis, you could see articular cartilage and spongy bone, and exactly here happens the process when where red blood cells will be synthesized. If you look at the diaphysis, In diaphysis you see a compact bone, a little bit of spongy bone. In the middle you easily see blood vessels and yellow marrow, fat. And in the long side of this femur, it covered with the peristome, which protects bone. Okay, compact bone. Osteocytes within lacunae, arranged in concentric circles called lamellae. This surrounds a central canal. Complex is called Haversian system. Canaculi connect osteocytes to central canal and to each other. Look at this diagram again. Look at the big picture, of the one part, one small piece of this long bone. You see here compact bone, and then it comes spongy bone. In the center you could see blood vessels and nerve. Nerve represents with yellow color. Look at the compact bone side. You see there are cylinders, lots of cylinders. Each cylinder has come from bone cells, osteon, and each of the cylinder has central canal. In each central canal you could find nerve and blood vessels, and all that central canal are joined together, linked together, and then go into the basic blood vessel in the middle of this femur. Okay. Development of bones. The skeleton of a human embryo is composed almost entirely of a type of connective tissue called cartilage. If you look at human embryo, it mostly consists of cartilage. Cartilage producing cells are scattered in a network of protein fibers, including both tough collagen and flexible elastin. Cartilage does not contain blood vessels. Okay, bone formation called ossification, it begins up to 7 months before birth. There are 3 types of bone cells: osteoblast, osteocyte, and osteoclast. Osteoblast secrete mineral deposits that replace the cartilage. As bone tissue completes its development, most osteoblasts mature into osteocytes. Osteoblast then gives osteocytes. What is osteocytes? Osteocytes help to maintain the minerals in bone tissue and continue to strengthen the growing bone. Bone remodeling and repair. The 3rd type of bone cell do this job. In many ways, bone is never finished growing. Bones are remodeling throughout life by small numbers of osteoblasts and osteoclasts, cells that break down bone minerals. Both types of cells work together to repair broken and damaged bone. Or with help of osteoclast, our bone at the end will have its general form. Okay, look at this. You see here picture labeled A, B, C, D, E, F. First you have cartilaginous model. It is cartilage. Then in B you see a little bit part which start to ossification, calcified cartilage. It starts in the middle of cartilage, not in the two end sides, in the middle. And then in the C you see that it will have blood vessels, compact bone development, and primary ossification center it has, yeah. And then D, and then E stage, and the last stage is F stage. Here you see our femur, which we already looked at, and that is why we say that long bones grow from its ends, okay? Because at the end, on the epiphyseal plate, mostly people will have cartilage, and with help of that cartilage, ossification of that cartilage, bone could grow. Adults continually break down and build up bone. Osteoclasts remove damaged cells and release calcium into blood. Yeah, osteoclasts, very good information. For example, in pregnant women, yeah, pregnant women should have special diet, which should be rich with calcium. Why? Because in other case, her organism will use her own calcium from her own bone, and it will happen with help of osteoclasts. Osteoblasts remove calcium from blood and build new matrix. They become trapped and become osteoclasts. Types of bone breaks: simple, compound, complete, partial, green stick, communicated, spiral. If you look at each of this, if you will choose medicine, you will easily know, yeah. Fracture repair, hematoma. In medicine movie or in daily life, you could hear this word hematoma. Hematoma, blood clot in space between edges of break. Yeah. Fibrocartilage callus begins tissue repair. Bony callus, osteoblasts produce trabecular structural support of spongy bone and to replace fibrocartilage. Remodeling, osteoblasts build new compact bone, osteoclasts build new medullary cavity. And here one example of bone break. Blood escapes from ruptured blood vessels and form a hematoma. Yeah, you see here hematoma. And then in B, spongy bone form in region close to developing blood vessels, and fibrocartilage form in more distant regions. You see it in the middle of this picture. C, a bony callus replace fibrocartilage. It become to make bony callus. Yeah, and D, osteoclasts remove excess bony tissues. Osteoclasts remove excess bony tissues and restoring new bone structure, much like the original one. And as you see, as you could figure out from this picture, why you should keep a person should keep his broken bone fixed, because then it could join in a not normal way. Okay. We could divide skeleton into two parts, axial and appendicular skeleton. For axial skeleton, we could say it is skull, vertebral column, and thoracic cage. Appendicular skeleton, it is pectoral girdle, upper limb, pelvic girdle, and lower limb. Here you are. In red, what do you think? Which one you see in red color? In red color, you see, as you look at this, axial skeleton, yeah, with the yellow color represents bones of appendicular skeleton. Okay. Okay, this information you all need for yourself to make your knowledge more interesting. Okay, in medicine, our students learn a human skeleton system like this, very deep, but we don't need that. Vertebral column, you should know that it consists of basic parts, cervical curvature, yeah, then thoracic and lumbar and pelvic. Okay, rib cage, here you could see the basic structure of the rib cage. It consists of rib and sternum, yeah, and also the spinal cord. Okay, joints. Joints also could divide into different types. Immovable, which will not move, yeah, which will not change its space, its place. Bones saturated together by connective tissue, for example, skull. And slightly movable, connected by fibrocartilage or hyaline cartilage. For example, our vertebrae, rib, sternum joints. For example, if you look at your vertebrae, you could see that you could move your vertebrae because it is slightly moved. And freely movable joints, which separated ligaments hold bones together. Tendons, yeah, for example, muscle to bone lined by synovial membrane. For example, you could say about your lumps. Okay. In this picture, you could be familiar with the type of joints and how it works. Okay. And how you could move your skeleton system. For example, if you look at your leg, you could move it eversion and inversion, elevation, depression, protraction and retraction. For example, rotation, you could move your arm like rotation, yeah, circumduction. Okay. Now let's look at the muscular system. There are three types of muscular tissues. First one, skeletal. Skeletal muscle, which is voluntary controlled. Smooth muscle, involuntary controlled, and cardiac muscle, involuntary controlled. What does mean voluntary controlled and involuntary controlled? For example, think about skeletal muscle. You have your skeletal muscle, for example, in your arms, hands, legs, feet, yeah? And it means that you, if you want, you could control it. If you want, you can raise your hand, yeah? Or your leg, you could move it. And now think about smooth muscle. Where you could find smooth muscle? Smooth muscle you could find in your digestive system. For example, in your stomach. You could not control your stomach work. Why? And how you could prove that? For example, you didn't eat a lot of time, let's say 5 hours. And then your stomach will release some voice, and you could not control that voice. You could not say your stomach stop doing that because it is involuntary. Smooth muscle you could find in digestive tract, in vessels, and cardiac muscle. Of course, you could not control your cardiac muscle and say your heart stop beating or start beating or pause then beat. Logically, yeah. Structure of muscle fibers. First, I would like to stop in the difference between of these 3 types of muscular tissue. First one, skeletal muscle. It has a lot more than 2, 3, more maybe than 3 nucleus, and it has lots of mitochondria on it. Smooth muscle consists from only 1 nucleus, and cardiac muscle, it is in structure it close to the skeletal muscle, and it also involuntary controlled. Structure of muscle fibers. Okay, look at this picture. Here you see that lots of mitochondria, yeah? In this picture you could count 3 mitochondria. And you could see fibrous, yeah? Sarcoplasmic reticulum, microfibrils, okay? And if you look at how muscle work, how muscle contract, you could find this answer if you look at its longitudinal picture. You see in this picture C, disc Z. Do you see that? H zone, yeah. If you look carefully in picture D, the labeled the place from Z disc till the end of the second Z disc, we call it sarcomere. Exactly, this sarcomere help our muscle contract. It means with help of this sarcomere we could walk. Look at a little bit closer. In picture D, you could see thin filament. We call it actin. And then you could see thick filament, which labeled with the red color. We call it myosin. Exactly with help of this action between actin and myosin filament, our muscle could contract. Okay. The filaments of actin and myosin overlap to give a distinct banding pattern when seen with an electron microscope. Models showing the arrangement of the actin and myosin filaments in a myofibril. Thick myosin filaments overlap with thinner actin filaments. Okay, and here represents different type of its types. Yeah. Okay. Exactly, myosin. You see their specific structure of myosin. Myosin will connect with the actin, and with help of that, to myosin shorten or increase, decrease the distance between actin filament, and that is why how our muscle will contract. Okay. We said large number of mitochondria in muscle, diagonal myofibril, sacroplasmic reticulum. Yeah, you could find all these things in this picture. Okay, I think this information you know. Sarcomere, you see here. You could then later, after our lesson, see and compare microscopic image and schematic image, and try to clarify more all that information. Yeah, look at this very, very good picture. Relaxed and contracted. When it relaxes, it has increased distance between between actin filaments. When it contracted, the distance between thin actin filaments decreases, and our muscle will move. Okay. Exercise and health. Regular exercise is important to maintain muscular strength and flexibility. Aerobic exercises such as running and swimming place strong demand on the heart and lungs. Look at this picture. Look at this man in the picture. You see, I think I could guess that he's maybe astronaut. Yeah. What do you think? Do you know what happened with the muscle of the astronaut when they are on the universe, when they are not on the Earth? Their muscle could lose their function, their quality. Why? Because they don't have such force which we have on planet Earth. That is why we have to make exercises. Exercise help to maintain normal, how to say, function of our muscles. Elevation and depression, aging and bones. Okay, if you look at aging and bones, you could imagine people who are, for example, in the Middle Ages, in their 30s, and old people are in their 60s or 70s, 80s, and I think you maybe heard that sometimes, not sometimes, old people have osteoporosis. Bone is broken down faster than it can be built. Bones get weak and brittle, tend to fracture easily. Both bone and cartilage tend to deteriorate cartilage. Yeah, you know that our bone is repairing, but in the old ages it is difficult to repair bones. Skeleton and other systems. Skin makes vitamin D, with which enhance calcium absorption. Very important information. Skeleton stores calcium for muscle contraction, nerve stimulation, blood clot formation. Not just a skeleton stores calcium for its own structure, but also we need calcium to muscle contraction, nerve stimulation, and blood clotting. And in red marrow of long bones, red marrow is the site of blood cell formation. Exactly in long bones happens formation of blood cells. Yeah. Okay. Growth hormone regulates skeletal growth, stimulates cell division in epiphyseal discs in long bones. Growth stops when epiphyseal discs are converted to bone. When excess growth hormone is produced in childhood, you could meet with giantism. In adulthood, acromegaly, bones can grow, but soft tissues can. Yeah. Okay, progression of acromegaly. You see how it happens. For example, this girl in her age of 9, then age 16, you see that in age 33, it is obvious that she has more tissues, more soft tissues rather than bones, and age 52, it is very obvious. Okay, and now I would like you to look at the video. This video could be the whole whole summary of our lesson. Okay, enjoy the video.
The human skeleton gives the body its shape and provides physical support for the systems contained within. It also forms part of the musculoskeletal system that enables us to move. The structure of bone is optimized so that it is strong but relatively lightweight. The interior of bone is composed of bone marrow. It is surrounded by two major types of bone tissue: cortical bone, or the hard outer shell of bone, and trabecular bone, the spongy-looking center. The amount of each type of tissue in bone is dependent on the function of that bone. The basic unit of cortical or compact bone is the osteon. It is composed of successive concentric lamellae. This structure contributes to bone strength by resisting bending. Cells called osteocytes are distributed within the concentric lamellae. Osteocytes form a complex network that is thought to be important in maintaining the viability and structural integrity of bone. At the center of the osteon is the Haversian canal. These canals contain blood vessels and nerves. The blood vessels within bone facilitate the exchange between osteocytes and the blood. Trabecular bone is present in the interior of some bones and resists compression. Osteocytes are also contained within its structure and again play an important role in sensing local changes in strain. Trabeculae are covered in a layer of flattened lining cells that are thought to be involved in the dynamic process by which bone is formed and broken down. Bone marrow is found within the interior of bones. The surrounding trabeculae and vascular network provide structural support, nutrition, and a waste removal system for the heterogeneous group of cells found within this space. Bone marrow is a site for hematopoiesis, the process by which the cellular components of blood are formed.
Thank you for your attention and I hope that you enjoy our today's lesson about skeleton and muscle systems. See you on our next lesson. Bye.